Today we will solve this problem. This is an interesting problem from complex numbers. You must attempt this problem one time before watching the solution. So let's start solving the problem. So what is actually given? Let A, B, C be three distinct complex numbers such that this relation is given. We need to find the value of K. So how we will do it? Let's see. So check out the relation first. Okay. From here we can write three things. A by 1 minus B is equal to K. Then we can write B by 1 minus C is equal to K. Then we can write what? C by 1 minus A is equal to A. Okay. Now what we will do? Cross multiply. Okay. So here we will get A equal to K minus KB. Okay. Here we will get B equal to K minus KC, and here we will get C equal to K minus K8. Okay. Now what you will do? Put this value of C in the place of this. Okay. So what we will get? We will get it will be equal to K minus K into K minus K, right? So we will get K minus K square plus K square A. Clear? We got a value of B. Now what we will do? We will put this value of B in the place of this B. Okay. So what we will get? We will get K minus K into K minus K square plus K square A. So what we will get? We will get K minus K square plus K cube minus K cube A. Clear? So if I write the equation clearly, what we will get? We will get A equal to K minus K square plus K cube minus K cube A. Okay. Now bring these all terms to the left hand side. So what we will get? If you take A common, we will get K cube plus 1 into A. Okay. Now here what we will get? We will get minus K plus K square minus K cube is equal to 0. Clear? I hope it is clear too. Okay. Now what I will do actually, take this minus common. So here this will be minus, okay, and this will be plus. Okay. Okay. So now notice one thing. Just do a quick observation, okay? So the observation is here in this relation, you can see that A, B and C are equally distributed, right? A, B and C are equally distributed. So what I did here actually, I took the whole equation in terms of A. Okay. If if you do not use A and substitute something like the whole equation will be in terms of B instead of A, what you will get actually, you will get the same equation, but here instead of A, here it will be B. And same thing goes for C. Okay. Why? Because that's very simple observation. You can also do it by your hands. Okay. This is a very simple observation and a quick observation that A, B, and C are equally distributed. Okay. So if I do this same type of work, but I want to get, if I want to get an equation, here I got the equation in terms of A, but I can use the same approach to get the equation in terms of B and C also. So what we will get actually, we will get the same equation. Okay, we will get the same equation. That means here we can get two more equations, that is K cube plus 1 into B minus K minus K square plus K cube. This is equal to 0. And also you can get K cube plus 1 into C. Okay, minus K minus K square plus K cube. This is also equal to 0. Okay, we will get the same equation. That's the main key concept of this problem. Okay, we will get the same equation. So now what you can do actually, from these three equations we can conclude for a general equation Okay, so if I write these three equations as a general equation, what it will look like? It will be k cube plus 1 into x. Okay, listen carefully. K cube plus 1 into x. Okay, and here it will be minus k square plus k cube. This will be equal to 0. Clear? What we got? We can conclude for a general equation k cube plus 1 into x minus k square plus k cube equal to 0. And what we can say? We can say that this equation has three roots a, b, and c. Okay, and these three roots are different because distinct complex numbers that is given. Okay, so these three roots are different also. Okay, so we can conclude that this equation has three roots a, b, and c. So now let's go for the next page. I am writing the equation again. So we got k cube plus 1 into x minus, and here it will be, what is here? K minus k square plus k cube. This is equal to 0. This equation has three different roots a, b, and c. Clear? Now check one thing. Here is the catch. The what is the variable term here? X is the variable term here in the equation. Okay. So now the highest power of x is equal to 1. Okay. So in general, if this is a valid equation, from where, what is equation actually? The equation is the relations from where we can find some fixed value or values of the variable. Okay, so if this was a valid equation, we can get only one value of x. Okay, that may be real or complex, but we will get one value of x, right? But in this case, we are getting three different values of x. Okay, we are getting three different values of x, but the highest power is equal to 1. That means this is a linear equation. If this is an equation, so what we can say that it's a linear equation. But we are getting three solutions. How that can be possible? That is not possible, right? Okay, we can't get three different solutions from a linear equation. We can't get that. Okay, so what we can conclude from here, you can say that this thing is an identity. Okay. Now, visualize the identity thing I discussed in my quadratic equation lecture. What is an identity? An identity is that type of relation for, and that will be valid for any value of the variable. Okay. Any value of the variable. Now, how this will be an identity? If this coefficient and this coefficient both will equal to 0, both will be equal to 0, then what we will get? 0 into x minus 0 is equal to 0. Okay, 0 into x minus 0 equals to 0. Now this is always valid, right? For any value of x, this thing is always valid, right? 0 minus 0 is always 0. This thing is always valid. So now that is the idea, that in order to make this an identity, we need to put the coefficients equal to 0. So let's do it. Okay, so we will get two equations, k cube plus 1 is equal to 0, and this whole term k cube minus k square plus k, this will be equal to 0. Clear? Now what we need to do, we need to find the common values of k for which this both become 0. Okay, which this for the both equations become 0. Why? Because you need the both term be equal to 0. Okay, to get an identity, in order to get an identity. Okay, so we need the values of k so that the both equations will be equal to 0. So let's do it. So if I factor this, it will be k plus 1 into k square minus k square minus k plus 1 equal to 0. Right? And here, if you take k common, we will get k square minus k plus 1 equal to 0. Now, from these two equations, can you notice the common factor here? you can notice the common factor, which is k square minus k plus 1. If this becomes 0, then this both equation will be equal to 0 together, right? Because this is the common factor. So let us put this equal to 0. So k square minus k plus 1 is equal to 0. Okay. So we can easily solve it. Okay, I tell to remember the result of this equation. So the results are k equal to minus omega and k equal to minus omega square. Okay, you can put the omega value of omega also. That is not the thing. Okay, but the two values are minus omega and minus omega square. You can may solve this and you can see that we will get the same values. Okay, where omega is, if you don't know, that is what omega is, minus 1 plus plus root 3i by 2, and so omega square will be minus 1 minus root 3i by 2. Okay, so that these are the two roots, minus omega and minus omega square. Clear? I hope it is clear to you. So we got two values of k, that k is equal to minus omega and minus omega square. This is the answer of this question. This was a very good question. I hope you enjoyed it. Okay. So if you like this video, make sure to like, comment, and share, and subscribe to our channel for more amazing videos and concepts. Thank you for watching the video. Happy learning.